My name is Tanner Jensen, and I will be doing my exam 2 optional corrections assignment video explanation. And so we'll start with problem 1. In problem 1, originally I assumed it was a diverging nozzle, but that would only get it to sonic speed. So I changed it to a converging diverging nozzle, which it would become sonic at the throat. And then when it diverges, it becomes supersonic. For the thrust, the two terms that I had were correct descriptions. I had the momentum out and the net pressure force, or otherwise known as pressure difference. Just during the exam, I didn't revisit the variables in time. And so I just defined the variables here, which was the mass flow rate times the relative velocity, which is velocity of the rocket minus the velocity exiting. And then for the net pressure force, it was the pressure exiting in gauge times the area of the exit. And so my K value of 1.4 still stands because I found it in table A-1. But other than that, the only difference in this problem was that I had made the wrong assumption with my nozzle, and then I also defined my variables in my corrections. For problem 4, initially, I had the T naught correct. I just didn't state it in Kelvin. So in the corrections, I did state it in Kelvin. My gauge pressure, my pressure, I forgot to convert to gauge in my original. And so in my corrections, I converted it to gauge before I found the exit gauge. And so I used the table in my corrections as opposed to the equations that I did during the exam, but I still got similar answers, or I would have gotten the same exact answers. So I solved the equations right. But this time for the pressure, I actually got it in gauge because I converted the P naught to gauge initially. And then for velocity, I was not solving it using any equations or methods that we had discussed during this portion of the class. And so I corrected that. I solved for C using the square root of KRT exit over M. And then I multiplied the C times Mach to get my velocity exiting. Where opposed in my original, I was just putting values together, hoping to get an answer. Then for problem 5, during the equation, I forgot what the ergon equation was. So this time around, I did some research and I found the ergon equation from our notes and I plugged it in. And then I converted it, or I pushed the row over to the other side of the equation to solve in terms of negative delta P. Then I needed to get it in Q instead of the velocity term. So the flow rate is equal to the velocity times area. So I multiplied the entire equation by area. And for the area, I expanded out the terms on the left side of the equation so that I can multiply it over to then solve for it in terms of negative delta P. Then for part B, I had mixed up my values, my X and Y's. And so I corrected that. I still solved by a system of equations to get my A and my B. So then for part C, I could then plug it in to the equation like I did. During the initial exam, I had rewrote the equation in a different way, which I didn't need to. I just needed to rewrite it into a quadratic equation and then solve for it using or into a polynomial, and then I could solve it using quadratic equation, which I did in the corrections. And then I got the options of 31.9 gallons per hour or negative 46.9, and you can't have a negative flow rate in this term, so I went with the 31.9 gallons per hour as the maximum flow rate that could be pumped through it when the unit or the PSI is at 60. And so during the equation, I pretty much flailed at the variables instead of sticking true to what we learned and what we're taught in class. Then for my next correction was problem 9. Initially, I didn't know how to solve this. When I went back through my notes and we're looking at this problem, I found the equation of the head loss is equal to the loss coefficient times velocity squared over 2g. I rewrote it in terms of the loss coefficient, and then I just solved for the value. Um, for problem 12, my only issue during the exam was that I had lost my water properties table, so I couldn't solve or I couldn't find the values I needed for solving the problem. I wrote out what I could do and how I would solve it, but unfortunately, I couldn't get further than that. I did make a wrong assumption initially, thinking that it'd be laminar. However, that was not the case. It turned out to be turbulent. Also, my K minor, I had initially used the gate, which was an exit effect, in my K minor, which was supposed to be neglected. So I corrected that with my K minor. And then I actually solved for velocity using the K or the flow rate over area equation, and I got a velocity for the problem. And I found my values using table A9 for the dynamic viscosity and the density of water at that temperature. And I also converted my roughness to meters instead of feet. Therefore, I found my Reynolds number, which was 105,441, which was more than 10,000, so it made it turbulent. I solved for my F prime using the equation. Then I found my friction coefficient major and my friction coefficient minor using their respective equations. Added those together to get my total friction coefficient. And then I used the Bernoulli's equation. We're making assumptions that both the pressures were atmospheric and the velocities were both standing water because they were on top of the surface, and that Z2 was the ground level. So I'd solve for Z1, which was the elevation difference or the elevation that tank point was at. And so when I solved for it, I got 5.07 meters. Again, my only problem during the exam was not being prepared enough and losing my water properties table before the exam. Thank you.